And this is about Sobel's mask and Privet's mask. So directly I am calling the Sobel's mask and I am calling the Privet's mask. I am taking an image, say A, and these two masks, it is going to act upon this image. So actually how it is done is, initially you will have an image and then you will have the gradient being performed over the image or the Laplacian being performed over the image, and the original image and this one will be filtered. So when you do this operation, the fine details alone will enhance and the remaining details, the background details and other details, they will be suppressed. This is how you get the enhancement. Let me run this one. It's a direct, I'm using the direct command here. So edge stands for edge enhancement sort of a thing. So this is what you are having, the original image. In this case, you can see it is only the edges are getting enhanced by using these masks. So this is not the actual output. Your actual output is this. This is with this is with Sobel's mask and this is with Privet's mask. So this is how the outcome of Sobel's and Privet's look like. So with this in mind, I will go to Laplacian now. I am taking the very same moon image because then only you can understand. I am using one Laplacian. So 4 masks we defined there. I am taking only one mask. The remaining 3 masks you can use and see how the results vary. So I am using a direct filter here. Laplacian filter I am using, which will act upon this image. Okay. I am having an outcome which is very much like your Sobel's and Privet's. But as I told you, that is not the final output. Because that does not look like a sharpened one, isn't it? It looks like only the enhanced. The details alone is enhanced. So when I run this, this is my original image. This is my Laplacian filtered image. Now you can compare the Laplacian filtered image with your Sobel's and Privet's. In Sobel's and Privet's, you were having only this circumference. You weren't having all these details because that is a single derivative. Whereas Laplacian is a double derivative. So you are having some more fine details are getting enhanced. Some more fine details are enhanced. So there we saw only these two things. But what is our final outcome? So this one and this one have to be again taken for processing. So when this is processed against this one, I'll be having enhancement in wherever pixels are available, and wherever pixels aren't available, they won't be enhanced. So what happens? My fine details will be enhanced, thereby it results in sharpening. So this is how the procedure of sharpening filters work. So you will have the original image. Your mask will act upon this original image and it will identify the suitable points of enhancement. Once those suitable points of enhancement are identified, then the second level processing, this image will be enhanced by these points, thereby giving you the sharpening effect. Okay. So in your previous thing, here we stopped with only the second stage. That is how that enhancement occurred. Okay. This is one enhancement and this is another enhancement. You can see the difference in enhancements between Robert's mask and Sobel's mask. You can see some pixels getting varied here. So whereas in your Laplacian image, you are having lot of fine details that is available here. So there we stopped with this. We didn't do this processing. So here I'm showing you the complete processing. the details are enhanced, and then you are getting this one.